Start.
Hi students, hello. I am Joydev, lecturer in physics from Sulaguna Higher Secondary School. Now I am going to teach about the atomic physics. Now I am going to discuss about the Bohr atomic model. Atomic physics means we study the character or behavior or structure about the atom. So we know that an atom consists of a nucleus with some electron revolves around its orbited or saturated orbits, and this nucleus consists of z number of electrons, z number of protons. That means a nucleus will be positive charge which collectively proton plus neutron. Now Bohr gives a model about the atom. That means the electron will revolve in a saturated or orbited orbits. At that time, what is the velocity of the electrons and what is the radius of that orbit from the nucleus and what is the energy of that orbit. That is the basic principles and basic concept about the atoms. Now Bohr gives some atomic models in 1913. First one is that when electron revolves around the nucleus in a saturated or orbited orbit or a stationary orbit, at that time the electron don't radiate any energy, don't radiate any electromagnetic radiations or energy. When the electron gains some energy from outside source, at that time the electron jumps from lower orbit to higher orbit or higher orbit to lower orbit when he lost the radiations. Due to the change of motions from one orbit to another orbit or initial orbit to final orbit, the frequency of the radiation is u dash is equal to EI minus ER by H, where H is the Planck's constant. Nu is the frequency of electromagnetic radiation. So Bohr suggests that when an electron is revolving around the nucleus in a permitted stationary orbit, at that time the total orbital angular momentum L is equal to a integral multiple of h square. That means n h by 2. Or in classical mechanics, we know that N is equal to mvr is equal to nh by 2. Now comes to Bohr's derivation about an electron. That means hydrogen-like atoms. Bohr assumed that when an electron revolves around the nucleus, electron's velocity v with mass m, then at that time the electrostatic force provides the necessary centripetal force The electrostatic force provides the necessary centripetal force to continue its motion in that specific orbit or orbital orbit. It means 1 by 4 by epsilon naught z square. Length is the radius of r or distance r from the nucleus to that orbit, that is r square, is equal to m v square by r. That is the centripetal force and that is your electrostatic force. The electrostatic force balances the centripetal force. We know that whenever an electron revolves around a nucleus or any particles continue its circular motions, then it's necessary a constant force and a constant acceleration, because force and acceleration concept, and acceleration must be necessary to continue its circular motions. That acceleration is known as the centripetal accelerations. V square by r is centripetal accelerations, and force is equal to centripetal force is equal to a v square by r. And that centripetal accelerations is electrostatic force is equal to centripetal force, that is 1 by 4 by epsilon 0 z square by r square is equal to m square by r. We know that from the postulates m vr is equal to m h by 2 pi, or implies that r is equal to m h by 2 pi m v. Putting this value in the equations, 1 by 4 by epsilon naught m s by 2 pi m v square z square is equal to m v square by m s by 2 pi m v 2 pi m v, or implies that z cancel, z square by 4 pi epsilon naught m h by 2 pi m v is equal to m v square, or implies that z square divided by 4 pi epsilon naught n h into 2 pi is equal to m square into mv equal to mv square, and then cancel, dv cancel, or implies that v is equal to 2 pi by cancel, or v is equal to z square by 2 epsilon naught h. That is your velocity of the electron. That is your velocity of the electron in a n orbit. That means v is equal to z square by 2 epsilon naught and h is the velocity of the electron in n orbit. When a specific orbit, so v directly proportional to z, because specific orbit n is constant, and when in a specific atom or element, v directly inverse proportional to 1 by inverse proportional to n. Specific orbit v directly proportional to z, a specific element v proportional to 1 by n or inverse proportional to n. Now, putting the value of v in that equation we get the radius of that orbit. That means r is equal to mh by 2 pi m z square by 2 epsilon naught nh, or is equal to 2 epsilon naught L square h square divided by 2 pi m z square. Two cancel, or implies that L square h square epsilon naught divided by m pi z square. That is the radius of an orbit from the nucleus of electron, or implies that r is equal to n square h square epsilon naught divided by m pi z square. That is the radius of an orbit from the radius, from the nucleus. Now we can calculate the total energy of an electron in a specific orbit. Then two types of energy we know. First is the kinetic energy and another is the potential energy. Kinetic energy means we know classically half mv square, k e is equal to half mv square. And potential energy, we have to calculate the potential energy. That means when an electron, if we bring a electron from radius to infinite distance against the electrostatic force, that is, some work is done against the electrostatic force, and that work is known as the potential energy. Now, first to calculate the kinetic energy equal to half m square is equal to half m v, the velocity of the electrons is here, z square by 2 epsilon naught and h whole square is equal to 1 by 4 m z square e to the power 4 divided by 4 epsilon naught square n square n square into 2 is equal to 1 by 8 m z square e to the power 4 whole divided by epsilon naught square n square h square. That is your kinetic energy of an electron. Now we calculate the potential energy, that is your work done against the electrostatic force when we bring an electron from infinity, from radius to infinite distance. So there is your potential energy Q, or PE is equal to minus r to infinity f dot is equal to minus r to infinity 1 by 4 pi epsilon naught z square by r square into dr cos 180 degree, because the force and displacement just in opposite or anti-parallel. Force is here and displacement is here. That means the angle may be 180 degree. So r to infinity 1 by 4 by epsilon naught z e square, the constant, is equal to dr by r square is equal to, here the position is there, cos 180 degree, the value is -1, so minus minus plus, z is a constant, is a charge of the electron is a constant, 4 pi epsilon is also constant, and the range from r to infinity is that I the radius or distance from the nucleus at infinity through which the electron bring from r to infinity distance, that is equal to z square by 4 pi epsilon naught r to the power -2 plus 1 by -2 plus 1 r to infinity is equal to z square 4 pi epsilon naught minus 1 by r to infinity is equal to z e square divided by 4 pi epsilon naught minus 1 by infinity plus 1 by r. That is equal to P E is equal to z square by 4 pi epsilon naught into 1 by r into 1 by r. But here the work done is the against of potential energy. That means the total work done is going to be negative, or if we not take here the negative, then it is also negative. So if we take it negative, then it is also positive. But here the potential energy or the work done is taken against the electrostatic force. So total work done or potential energy is equal to minus z square by 4 pi epsilon naught 1 by r. So total energy is equal to k plus p e, that is equal to 1 by 8 z square into the 4 by epsilon naught n square minus z square by 4 by epsilon naught 4 by epsilon naught so total energy is equal to 1 by 8. We know that what is the value of r? What is the value of r? m z square e to the power 4 epsilon naught square n square h square minus z e square divided by 4 pi epsilon naught. And now we putting the value of r n square h square epsilon naught by n square h square epsilon naught divided by 4 pi m. Sorry, n square h square epsilon naught by pi m z square, pi m z square, or is equal to 1 by 8 m z square e to the 4 divided by epsilon naught square n square h square minus, here pi by cancel, m z square e to the power 4 divided by 4 epsilon naught square n square h square is equal to minus LCM, take it LCM 8 epsilon naught square n square h square a z square e to the power 4 minus 2 times of m z square e to the power 4 is equal to minus m z square e to the power 4 divided by 8 epsilon naught square n square h square. That is your total energy of the electron in an orbit, which is when the Z is constant, that means in a specific element, then E inversely proportional to the square of n, and when for a particular orbit E directly proportional to z square. This is the calculation of the radius of a specific orbit from a nucleus, and the velocity of electron in an orbit, and the energy for a particular orbit. Now, R is the radius of an electron in a specific orbit. That is R equal to epsilon naught m square h square by pi m z square, and V equal to z square by 2 n h epsilon naught, and total energy E is equal to minus m z square e to the power 4 by 8 epsilon naught square n square h square. O implies that total energy E equal to 1 minus 1 by 8 m z square e to the 4 by epsilon naught square n square h square into 1 by n square, where n is equal to 1, 2, 3, n the integers, and here n equal to 1, 2, 3, 4 onwards. If we get n equal to 1, তাহলে E 1 is equal to minus 1 by 8 m z square e to the power 4 by epsilon naught square h square. If n equal to 2, E2 is equal to minus 1 by 8 m z square e to the power 4 by epsilon naught square h square 1 by 4. When the value of n is slightly increased, then at that time the energy, the value of energy is goes to less negative, that means 1 When n equal to 1, the total energy E1 equal to minus 1 by 8 mz square to the 4th by epsilon naught square. When n equal to 2, E2 is equal to minus 1 by 8 mz square to the 4th by epsilon square to 1 by 4. When n is increased, the energy is less negative, so that the higher orbits, the electron cannot bound in longer times. So here n equal to 1 is called the ground state, and which is the more negative value. So the electrons bound by the nucleus in a ground state is more stable than n equal to 2, n equal to 3 and n equal to 4 etc. So here for higher negative value, the orbit is more stable than lesser negative, so that electron can easily bound and stability in the ground state or ground orbits. Or then the energy level for a hydrogen-like atom slightly increased from ground state to onwards. Ground state to onwards. So ground state is the most stable state in which the electron can revert in the Fermi-meter or saturated orbits, and the energy of the electron or the orbit of the electron slightly increased towards the intrinsic value of the air.